There's a really specific kind of tension that exists when a truly engineering mind comes up against the natural world.
Oh, absolutely. Think about it.
Yeah, if you're a software engineer, your whole world is logic. You build these systems where, inputs have predictable outputs. If A plus B doesn't equal C, there's a bug.
You find the bug, you fix it, you recompile, you are in control.
And then you go outside and step into a garden.
And suddenly you're in a world of infinite edge cases. It's chaos. It's reactive. And it definitely does not follow the documentation.
That is exactly the clash we are exploring today. We're looking at what happens when you take that super rigorous structuralist mindset, the mind of a software plumber, as he calls himself, and you apply it to a chaotic, invasive vine.
And our source for this is just a fantastic blog post from qianmeng.org. It's titled Notes on Gardening, Part 799, The Practical Evaluation of Coral Vine.
Part 799.
I know, we have to just stop on that number for a second. That sets the tone for literally everything else. This is not a casual hobbyist update.
No, this is a longitudinal data set. The post was published today, February 6th, 2026, by the author, Ang. And you're so right, for him, gardening isn't just a hobby.
It's system administration.
Yes, he's managing a live server, and his coral vine is like a new piece of software he's installing just to see if it crashes the whole system.
That's the perfect way to frame it. So the mission here for our deep dive is really about the art of practical evaluation. He is not writing a love letter to a flower.
No.
He's conducting a stress test. He's assessing this new thing through a lens that is almost, aggressively analytical.
Which I find so refreshing. So much garden writing is, the dew on the petals and that kind of thing.
Right.
Ang is looking at unit economics and structural integrity. So let's get into the subject of this stress test. The plant is Antigonon leptopus.
Better known as the coral vine.
And visually, it's really pretty.
Oh, it's stunning. The photos he provides show these really dense clusters of vibrant pink blooms. But what's interesting is what he focuses on, which is the foliage. He describes the leaves as light green, heart-shaped, and having this really distinct crinkly texture.
I love that detail, crinkly. It gives you a real tactile sense of it. It's not some smooth, glossy leaf.
It has topography.
Exactly. But he doesn't just stop at describing it. He immediately runs a kind of pattern recognition algorithm in his head. He looks at this coral vine, and what does he see?
He sees a Bougainvillea.
Of course.
It's the obvious comparison, right? For anyone who does any tropical gardening. The flower shape, that intense pink color, it's a dead ringer for Bougainvillea.
But Bougainvillea is the standard. If you drive around any warm climate, it's like the Microsoft Word of landscaping.
Everybody uses it. It works.
But it's everywhere. So Ang points to the coral vine as a solid choice for an alternative. If you want that look, that riot of pink, but you want to, fork the code and run something a little different from your neighbors, this is your plant.
It's a great candidate. It's distinct. It might even be hardier in some ways. It just breaks the monotony.
But every new software installation comes with dependencies and maybe a few bugs. And reading Ang's evaluation, the bug with this coral vine seems to be its operating speed.
It moves fast, incredibly fast.
And that's where the real engineering challenge starts.
Right. He flags the plant as invasive. Now, in gardening, invasive is usually a bad word, but from an engineering perspective, what does that really mean? It just means the process consumes all available resources.
A memory leak.
It's basically a memory leak,
Yes.
It's drought-tolerant, which is a feature. It's low maintenance. If your goal is just survival, you can neglect it and it'll keep running. But if you care about the output, the aesthetics, it becomes incredibly high maintenance because you have to constantly be restricting it.
You have to keep killing the process to stop it from crashing the server. He says the pruning is significant. But the real friction in the post, the core problem, isn't just growing the vine.
No.
It's where he's trying to grow it.
The container problem.
All right, he's not putting this in the ground where it could just run wild. He's trying to cultivate this super aggressive, fast-growing vine in a pot.
And that's a physics problem as much as a biological one. Ang even notes that managing a vine takes a very different and challenging approach compared to, a standard upright plant.
Well, think about the architecture of it. A shrub or a tree has a defined structure. It's got a main trunk. It fights gravity in a predictable way.
It's like object-oriented programming. You have your class, you have a hierarchy.
It's all contained. A vine is totally different. It's fluid. It has zero respect for boundaries. It just sprawls and tangles. Trying to grow that in a container is like, I don't know, trying to keep water in a mesh bag.
You have to build the structure for it, the trellises, the supports, and you have to constantly be guiding it. If you don't, you get what developers call spaghetti code.
A tangled mess where you can't even find the beginning. And Ang is very clear that the goal is to keep it aesthetically pleasing. That's the key requirement.
Anybody can keep a weed alive in a bucket. But making it look intentional, that's the software plumber skill set coming into play.
And speaking of that persona, to really get why he's even doing this, we have to look at the guy himself. We mentioned his blog's sidebar. It's not just gardening notes.
Not at all. It's the resume of a polymath.
It's wild. You're scrolling and you see notes on gardening, and then right below it is notes on Erlang, notes on Haskell, notes on Elixir.
And let's be clear, those aren't just any programming languages. They're functional programming languages. They're known for being incredibly strict, mathematical, all about immutability.
Pure logic, no side effects.
Exactly. And yet, this is a man who spends his free time with a plant that is nothing but side effects.
It's a fantastic contradiction. He's got a mind that craves order and syntax, and he's also tracking betta spawn logs.
I saw that. He's logging the reproductive cycles of his fish. And notes on dieting, notes on guitar.
You document everything.
It really suggests a worldview where everything is data. Life isn't just a series of experiences you feel, it's a series of data sets to be captured and analyzed.
And optimized, which totally explains his approach to this vine. The garden is a legacy codebase. The plants are different modules. Some are stable.
And some, like the coral vine, are volatile. His job isn't to nurture them in that fuzzy traditional sense. His job is to refactor the garden. He's debugging growth patterns.
And the documentation is key. You never write code without comments, right? So this blog post, part 799, is just the documentation for the latest commit to his garden repository.
It creates this distance, which I think is actually really healthy. If the vine dies or it looks terrible, it's not a personal failure, it's just a failed experiment.
The data suggested X, the result was Y. Adjust parameters, rerun.
Exactly. And speaking of his parameters, he raises this really interesting philosophical point about how he gets his plants in the first place. He has a rule.
He prefers seeds.
Yes, which is the classic builder mindset. He says the true joy of gardening for him is seeing the entire life cycle, from seed all the way to maturity.
It's like not invented here syndrome, but for plants. He wants to compile from source.
That's the perfect analogy. When you buy a mature plant from a nursery, you're downloading a pre-compiled binary. It just works.
Right out of the box, you get your flowers immediately. But you have no idea how it was built. You don't know the root history. You didn't write the code.
But if you grow from seed, you understand every single line of that plant's existence. You oversaw the whole execution.
And this is where that practical evaluation part comes back in.
Yeah.
He broke his own rule for the coral vine.
He did. He bought a mature specimen.
He sold out.
No, he optimized. And he gives two very specific, very logical reasons why. The first one is immediate evaluation.
Latency issues. Can't wait for it to compile.
Right. If he starts from seed, he's waiting months, maybe a year, to see the blooms, to test how it handles drought. He wanted to audit the software now. He wanted to know if this was a good alternative to Bougainvillea today, not in 2027.
Makes total sense. You demo the software before you commit to building it yourself. What was the second reason?
Propagation. He says he bought it specifically to harvest cuttings for future propagation projects.
So he bought it to fork the code.
He bought it to fork the code. He sees the mature plant not as a decoration, but as a resource generator, a mother plant. He can take cuttings from it, clone the repository, and then run a bunch of parallel experiments.
Try one in a different pot, one in the ground, give one to a friend to see how it does in their environment.
It's incredibly strategic. Most of us buy a plant because, ooh, that looks pretty. Aang buys a plant because it fits a very specific slot in his resource management plan.
And all of this brings us to what I think is the most surprising part of the entire post. He just openly admits that he isn't even particularly fond of vines.
I know, I loved that admission.
It just flies in the face of how we choose our hobbies, right? We do things we like, we do what feels good. Why on earth would you bring an invasive, high-maintenance plant you don't even like into your life?
For one reason. Market conditions.
That just killed me. Market conditions.
He says he saw they were widely available and the price was low at the local nurseries. The barrier to entry was basically zero.
So the logic is, even if I don't like vines, the cost of acquisition is so low that the value of the knowledge I'll gain by testing it is worth more than the price tag.
It's curiosity over comfort. And maybe data over
It
preference.
is. He's willing to step outside his own bias. He thinks, I'm not a vine person. A normal person stops right there.
An engineer thinks, I'm not a vine person, but the data suggests I should verify that assumption because the test only costs $5.
That's such a powerful takeaway for anyone. How many things do we just not try because we have this hard-coded identity? I'm not a math person. I'm not creative.
And he's proving you don't have to identify with the activity to evaluate it. You just have to run the script and see what happens.
And you gain a new data set no matter what. If he hates it in 6 months, he can just compost it. He's at a few dollars, but he has 6 months of data on Antigonon leptopus growth rates.
So the project is still a success because the goal was knowledge, not just decoration.
It also reframes what low maintenance even means. He says the plant is low maintenance because it doesn't die, but as we've been saying, it's structurally very high maintenance.
And that's a really important distinction. Maintenance is a vague word. In our own lives, we sometimes confuse survival with thriving. Just keeping your job might be low maintenance. You show up.
But turning that job into a career.
That takes pruning, shaping, trellising. That's cultivation. Aang is willing to do that cultivation work even on a project he's not totally sold on. And that's the discipline that gets you to part 799.
That's so true. And there's an open source ethos to this, isn't there? He's publishing his notes. He's open sourcing his garden.
Exactly. He's sharing a documentation. He's saying, look, I ran this test. Here are the bugs I found. Here are the features. If you want to run this code in your own garden, here's the manual.
It turns a solitary act into something useful for a community. It really makes me rethink the value of just documenting the small stuff. We think we have to write a whole memoir.
No, Aang just writes notes. But 799 notes later, you have an encyclopedia. It's the compound interest of just paying attention.
So if we pull back for a second, looking at this coral vine through Aang's eyes, we see a plant that is this beautiful, deceptive challenge. It looks like a Bougainvillea, but it acts like a weed.
And it requires the hand of an engineer to keep it from becoming, spaghetti code.
But we also see a whole methodology for living, the software plumber approach. Strip away the emotion and just look at the variables. Availability, cost, growth rate.
Structural requirements. And being willing to prune, I think that's a huge part of it. You have to be willing to cut things back, even healthy growth, if it doesn't fit the architecture you're trying to build.
Absolutely. Unchecked growth isn't design, it's just chaos.
Directed growth is design.
So I want to leave our listener with a final thought on all this. We've spent this time inside the head of a man who is writing version 799 of his gardening documentation. He is literally debugging his reality, one plant at a time.
He's paying attention. So much of it is just that.
He didn't just buy a plant, he bought a data set. So here is my challenge to you. If you stopped looking at your own hobby, I don't care if it's cooking or running or even listening to us right now, as just something you do for fun, and you started treating it as a source of data, what would you find?
That's the version 799 mindset right there.
If you had to write a practical evaluation of your own habits right now, today, would the code compile? Or would you find a few invasive vines taking over the container?
Time to start taking notes.
Thanks for diving deep with us. We'll see you in the next compile.